Okay, so the YouTube live is saying that it's waiting, right? Oh, there you go.
Okay, looks like it's noon, and we promised we would be on at noon, so we're on at noon. Welcome to the Ansible Toronto for March 2020. This is normally an in-person meetup that's now definitely not in person. We know the state of the world today, and we decided to do an online meetup. My name is Aaron talking right now. Normally I organize the meetup. And I work for Arctiq. We're a small services firm in Toronto, and we happen to be highly invested in things like Ansible and automation and things like that. So it seems very opportune that we can host the meetup and keep it going like this. So what we have today is 3 different speakers. We have Marek Anderson, we have Ricardo, and we have Eric Wright. And what I'm going to do is just start by sharing a little bit of our updates that we typically do for the meetup and a little bit of the agenda, and then everyone will go through their talks. And we're anticipating this will go roughly 2 hours and by approximately 2 o'clock. If we're earlier or later, that's cool too. And if we're going to do any Q&A, we'll talk about that in a second. But as for what we're going over, I guess welcome back if you've already been to our meetup in person. So we know the current world situation. I just want to make a call out and recognize, thank all the frontline support staff, everyone who's doing all the help to make it comfortable for us to all work at home too is all a big deal. I want to say a quick hello to the regulars as well as the new people, because now that it's a sort of now that it's on the internet, I mean, we don't care if you're in Toronto or not. Go ahead and join this live stream and see what we're up to. Consider standing up for a bit. This is 2 hours, and we don't expect you to sit, for 2 hours straight, and that's not good for your health. Jump up, sit down, stand up, sit down, and it's good to see that we'll have some activity. 2 hours of talks. We want people to not be totally sedentary the whole time. Q&A we'll do via YouTube live chat. So most of you should be looking at this, if not all of you should be looking at this via YouTube live chat. And we want you to know, as people viewing this, there is a 7-second or so delay between what we do and what you hear and see. So if there's, when we do the Q&A sessions, it will take a little bit of time for some of the responses to come back. So just bear in mind for some of that. We're going to do sort of a little bit of Q&A, general sort of chatter maybe at the end of all of the Q&A and all of the sessions. And then anything that you want to talk to us about after the event, feel free to message us, tweet, LinkedIn, Slack if you're on there, such and so forth. And that would be all fantastic, fair and good. We should say thanks to Arctiq, Red Hat, StreamYard, and YouTube. All 4 is what made this possible for us to do today. If you're looking for a way to do sort of all-encompassing within the browser streaming to different services, and you need a different way to handle the switching and management of all the tasks, StreamYard has been instrumental for this. And thanks for the speakers for stepping in today. In case we do need to end early or something to that effect, I just want to thank them ahead of time for stepping up and giving a good presentation for what we're, the topics we like to hear about on the Ansible Meetup. So what we also like to cover is things like, like a quick update to cover, what's going on in Ansible lately. I call these the notables. So we know that Ansible 2.9 is currently out, and we know that quick reminder, collections is still proliferating gradually. It's in release. If you're not familiar with Ansible collections, you've probably got some homework to do if you're busy with Ansible on the regular. As for modules. This we already called out the last time, but every module that ends in underscore facts is going to get renamed to underscore info. So just a quick reminder in case you're porting playbooks or shifting code around, everything that was previously underscore facts is being renamed to info. Ansible, in the most recent 2.9 dot something, we've seen a lot of, not a lot, but a good number of changes in anticipation for collections and automation hub with the Ansible Galaxy piece of the product, and numerous Python 3 fixes. That's probably in anticipation of what's going on with being able to adaptively look at which interpreter is on the host machine that you're hitting. So that's interesting to see. We've got Tower in 3.6.3, a really noticeable change here. Support on all versions older than RHEL or CentOS 7.7 is being deprecated, meaning that all future versions of Tower will require a minimum of 7.7 CentOS or RHEL. So that's an interesting requirement. And then if you've been active with CloudForms or ManageIQ, as it connects or integrates with Tower for inventory source, that's being deprecated as well as of 3.6.3. And in a future release, which we don't yet know, they're going to completely disable the inventory source of CloudForms ManageIQ. Other things we're seeing. So integrations, a number of them, but the ones that seem to be sticking out lately is putting Tower into OpenShift. And if you're not familiar with OpenShift, it's the Red Hat distribution of Kubernetes, and Ansible and ServiceNow. So we have a talk about it today because it's been so popular. A lot of customers are using ServiceNow as sort of the front end for a lot of their infrastructure config management actions, and Ansible is the workhorse behind it. There's a good, healthy uptake in Ansible operator writing. So we're seeing a lot of that activity both on GitHub and with a number of customers that are interested in, automating things like typical operational tasks that you need done inside an OpenShift or Kubernetes cluster. You don't have to write Go code for that stuff. You can use Ansible now, which is really awesome. And we're seeing the same sort of adoption uptake with infra as code as a practice in many of our customers. And this is good to see because Ansible feeds that, and it's just all good for the whole everything as code philosophy that that we really like to do. As for our agenda, here's what we're going over. We've got Eric Wright on Ansible and Terraform as a perfect pairing. We've had a similar talk about this by Mark LeBlanc in the past, but he's going to go on a slightly different tangent. Then we're going to do a little bit of Q&A, and for Q&A, just so you're aware, I'm going to kind of moderate the questions that we see in the YouTube live chat and pass them to the presenter, and they can go ahead and do their response. That's what Q&A is going to look like today. Marek Anderson is doing Ansible and ServiceNow integration. As I was saying, it's been really popular and there's been some updates, so we want to see what that looks like. And then we have Ricardo Gerardi doing Ansible testing with Molecule. I've seen activity, and many of us actually have seen activity with using Molecule with Ansible, but we haven't actually seen it put to use or to the test, and it's good that he's bringing up this topic. It was really important to get this one in for this meetup because we don't do it as frequently. A little bit of Q&A and then some general Q&A if anyone has any last minute questions and closing remarks. Ideally, we finish by maybe 2:15, 2:30. That's cool. And we'll see how it goes. So that is our agenda. At this point, we're going to kind of, I think I can pass it to Eric Wright. Just give me a nod, man, and I'll bring you up.
Ready to roll.
Okay. So,
all right. I think that's we should have that like guests of the online meetup stay at. And also big thanks obviously to the entire Arctiq team for everybody for jumping on. I hope this is helpful and I wanted to cover. It's kind of funny. I feel like a bit of a wolf in sheep's clothing whenever I come to a meetup for another thing and talk about something different than the thing the meetup's about. But it is important because I'll talk to you Ansible and Terraform together, and hopefully this is helpful. Definitely, if there's any questions that come up, we'll catch them as I switch over. I'm just going to run through a quick couple of slides, and I'll actually demo what it is that I'm doing, so we know kind of where it's at. So also big shout out to all the oatmeal and bacon that's going on. So I ate breakfast early, so I'm going to try and mush my way through this without getting too hungry. So my name is Wright. I'm the technology evangelist at a company called Turbonomic. And I'm online is the easy way to find me. I'm Disco Posse. So I write at discoposse.com. I have a podcast. Everybody has a podcast, I think, but I do as well. And so I said by daytime, I'm doing I work and I lead the technical marketing team along with Jacob Ben David. If you're in Toronto, you may know Jacob. He's wicked cool. He's my peer at the technical marketing team at Turbo. So he's also a big shout out to Cloud Ops and all our friends, if you're familiar with those folks. Anyways, let's get started. The reason why I talk about Ansible and Terraform as a pairing, and hopefully this doesn't sort of step on a lot of repetitive stuff that Mark LeBlanc covered in the past, and hopefully it's not too kind of training wheels in the way that I'm talking about it. But the goal that what I'm finding when I talk to different customers and folks in the community, and even just coming out of a background, I did 20 plus years of architecting data centers and clouds and building container infrastructure, OpenStack. Yes, I was one of those. The idea that we have is that can we make infrastructure that can kind of power itself and control itself? And I've always loved introducing this idea to people, even at the smallest scale. But the problem, I've got a lot of people that are still just figuring out, if you listen to the pundits, they'll tell you that everybody's going to cloud, everybody's doing infrastructure as code, too late. It's actually not true, as you folks know that are there. What I also know is that after how many years of being sold a single pane of glass doesn't exist, so I want a toolbox. Like I want to use the best possible thing for each thing that I need to get done, not this kind of like Swiss Army knife, it's kind of like a toaster oven, which is a very poor toaster and a very poor oven, but it's halfway of both. And also what I'm finding more and more is as we get adoption of these products, is how do we get people to move towards collaborative use of it? Infrastructure as code is only good if you're actually collaborating in code. So that's the whole thing of the code base has to be the source of truth. And really, so I want to identify how I use Terraform relative to Ansible. I've actually done this in the past in production environments a lot, and I'm helping folks in all the time. About every week I'm on some kind of a call helping with Terraform and Ansible generally in a customer environment. Now, these are two pretty cool tools. They are fairly neatly divided in what one does well and what other one doesn't. I spend way more time above this line. So I do a ton of stuff for Terraform. I surprisingly don't work for HashiCorp. I just really enjoy the product. So if you're looking for a lot of stuff here, I blog about it. I've done a lot of presentations and I work more in code there. Ansible, I sadly have not done as much as all the folks that are on here, but I love it because I'm actually going back into it pretty heavily right now because I'm doing more and more integration through work. So it's kind of cool. The separation of what's good about each tool really is number one, Ansible, as you folks know who are here, it's really wicked good at application deployment, being able to do continuous configuration management. The challenge that I think we find all the time is that when we look at config management, you have the problem of, what are the right tools? I've used Chef, I've used Puppet. Each has their own oddities. The way that order works. Also, as good as you are at any particular version, like we talked about, Aaron said at the start, we're changing the whole structure, right? So all your playbooks are super good right now. They're going to be not so super good soon. And I bump into this with Terraform as well all the time as we see the versions get updated. Now, Ansible also very good at ongoing operational stuff. So I don't generally want to use provisioning tools for ops management. And I'd love to think that everybody just destroys their infrastructure and then rebuilds it from a code base every time. And we all know that's actually not true. Like, we actually do patching. We do all of these things. I'd love to think that everybody's just going to live in containers and that's how it's going to go. Not the case. And if you're in Ansible also, like, the advantage is you're used to the format and flow of a playbook. I say easy to read. I should have put an asterisk there. It's only easy to read if you know what a playbook is supposed to look like. But just that format is nifty, just because I think it's visually just very, very nice. On the Terraform side, one thing Ansible doesn't do so well: initial provisioning of whole infrastructure. Now, when we get into cloud stuff, this is where it's really cool, because I can actually do, in the course of about 180 lines of code, completely build an entire VPC, front-end load balancers, all the certificate management system, everything on AWS. And it's literally just spin it up, tear it down. And I run a lab in my environment, and as a part of it, I have to actually do that all the time for an education team. So we spin up like 45 instances. Each of them has its own fully qualified DNS name, its own certificate. It's available online. And then when we're done the class, we tear them all down. So it's a beautiful job for this. So it's really an infrastructure provisioning tool. Look, it's a lot more. And if we had a HashiCorp person, they'd probably yell at me for calling it that. But that's generally what I use it for, and what I find is good at. And again, the most important thing is I call it cleaning up after your pets. You can actually shut everything down with it. And I bet you've got a bunch of security groups that are called Launch Wizard 27, Launch Wizard 28, right? We end up with all this crap in our environment, and we don't actually go back and clean it up. So this way, whatever you stand up, it goes away when you deprovision or destroy it. And also the fact that if you're using Terraform as a CLI, I'm going to show you in the cloud tool. Now, cloud is free for, I think it's up to 10 users. And Terraform Enterprise it's a nominal cost relative to some of the other products out there. So again, I don't work for HashiCorp. If you buy some, so be it. I can hook you up with a person that knows it well. So the life cycle that we're going to talk about today this is the flow that I'm going to use. Very simple. I'm going to use Terraform. I'm going to spin up an environment that basically kicks over, and it's going to deploy Ansible. And then this is sort of the virtual handoff of where we're in Ansible land. From that point on, you have living infrastructure, and then we're going to manage it, through Ansible. So that I'm not going to do a ton of stuff in the Ansible side of the world, because you already know that. I don't need to tell you where it's at, but I'll show you where the handoff is and some of the hooks you got to watch for. And then the teardown is also, now it's in Terraform, which is great, because now you've, again, like I said, no leaving crap behind. You can stand it up, tear it down. And with Terraform Cloud as well, it does continuous shared state management. There's also a problem with the CLI, because you don't share state. You could use like Gruntworks and a bunch of other things to try and like hack it together, build your own backend in S3 or console with some weird plugins. It was not really particularly good at it, because it doesn't keep rechecking state. So if you've got long living infrastructure, it kind of gets out of whack, and then your Terraform becomes a problem, and you have to sit there and always taint all your objects because it thinks they've changed just because the cloud moves around. So the expanded version, if you're really kind of into completely, making your whole infrastructure immutable, you can actually make your development station. So you can deploy everything. So I've actually done this where you build a Vagrant box, and then it has Terraform, all the things you need in there, and then it triggers Ansible, and the reverse happens, right? So I'm going to do more. Maybe we'll do it on a different time, and I'll write a blog about it. But today, like I said, we're just going to go kind of like the standard run-of-the-mill one. So here's this is the stuff for folks that have already used Terraform. You may know some of these things, but one of the things that's going to really kind of hit you hard is if you're going from the CLI into cloud and enterprise, you are moving towards using a cloud version, so you don't control local. There is no more local. It spins up a new container in Nomad in their backend environment. It has a basic Ubuntu image with a limited set of libraries in there, and it runs. So you can run certain shell processes and such, but when you say local exec, there is very little things you can do. You can't just dump in like 45 tools and libraries and then use them. So it's tricky. So this is where you have to change. If you're using local exec a lot today because it's on your workstation, you're going to have to sort of change your pattern. The other thing is secrets management. It's actually way easier now because you can actually do secret management in the Terraform cloud. You don't need to stand up a Vault installation, or if you're using CyberArk or whatever those tools are, whatever your tool of choice is. And I know most people's secret management is VI or Notepad somewhere out there. Obviously, there's a couple of different iterations, but programmatic secret management, you can do it right in the tool, and I'll show you how. Feedback between Terraform and Ansible. I'll show it again sort of quickly where the handoff is. What's neat is you can take variables inside your Terraform configuration and pass them into Ansible. So as you're doing passwords and other configuration management for that initial push, you can let Terraform do it. Now remember, Terraform is basically pushing the boat out into the ocean. And from that point on, it's an Ansible boat. So we'll show you the way that it syncs up. And the neat thing is, if you actually remove, you can do a destroy command. So as you destroy it, it will push like kind of a deregistration from Ansible or CMDBs or ServiceNow or whatever it's going to be. So there's kind of neat ways of standing up and tearing down programmatically. Now, one thing to watch out for, when you do configuration changes where it sets a provisioner, like where you're running a command or doing a lot of functions in Terraform, it will actually destroy and re-provision the environment when it's out in the cloud. So watch out for that, because if you are storing any local artifacts in the machine that have been built up, or you've been running Ansible do configuration management, remember that if you change something and you try and do a Terraform apply and it updates, build it. I just got to give my shameless plug. I talked about the fact that Nomad's actually powering the back end of some of the stuff, and I have a Pluralsight course on HashiCorp Nomad. That's all. Shameless plug is over. But the code that I'm going to show you is actually sitting on GitHub. So the easy way, don't worry about the whole big URL. This presentation is actually in there as well. So if you just look for Disco Posse in GitHub, super easy to find. There's definitely only one of me. Probably, thankfully, as Kyle and all the folks here would say. Okay, I'm just going to go and try and reshare now. I'll get over to my. All righty. Haha. So I see a couple questions coming through. We'll try and catch those in a second. Okay. All righty. So I'm going to show you quickly in the code what this is going to look like. So this is you can see this in the GitHub. I won't go exhaustively through it. Couple of notes which are also in the README. We're going to set up a security group for this particular instance that's going to deploy an EC2 instance from an AMI. The AMI contains some content already. You could use Packer or something else to build your images, but I've just pre-built my AMI. So I have to open up port 80, port 443, because there's a web app sitting inside it. I'm also doing this, and hopefully, make sure I can see. Yeah, you're seeing my screen. So the ingress for SSH is 0000/0, which is a terabad thing to do. So what you want to do is make sure that as you're doing this is the initial provisioning. Ideally, you should have it only open up to your Ansible, control machine, like a Bastion host. But you can set it up for the launch because you need SSH for the initial provisioning of Ansible if you're doing a ground up build. And then at the end of part of the Ansible build, you can actually then tear down the security group. So it's kind of a neat thing where you can actually rip out the supplies at the end. So basic thing, I've programmatically set all of these through variables. You'll show them in the Terraform config in a moment. Set a couple tags so I can keep track of where things are at. And this is where the handoff is. So right now, what I'm doing is, as part of this provisioner in a remote exec, so as I stand up this machine, I'm going to use SSH, and I'm going to store the SSH key in a secret. It will then go out. It will do the initial installation. So it's just going to simply go in, deploy Ansible, and then you would have the additional commands inside here would be, setting up your first playbook, setting up your host, setting up everything else you need for your Ansible environment. I didn't want to do a lot here because this is a shared, repo, but I'm going to blog about how to actually do all those things. But it's very simple. Simply, this is what you do. You can echo stuff into a script file. You can do a pull from a GitHub repository. There's lots of different ways you can inject those initial configurations and those playbooks And then it will do a whole lot of other stuff, which is setting up a load balancer, setting up a DNS information and such. Okay, back and forth. I tried to share my whole screen before, but it made a weird thing where I was actually blowing out the window because it was a mirror. So, Chrome. Okay, hopefully this does this. Now, I do have to ask, because I can't see the other tab. Are you seeing? Oh, no, man, sorry. I'm trying to share the my Terraform configuration. Alrighty. All the skills we have in the world, but it's really hard. There we go, Rapid Matter. Aha, perfect. Okay, so for folks that are familiar with the Terraform cloud, so I've set up a basic a workspace here. You can see a bunch of runs have already happened. And today, if I look at the current state right now, this is the last thing I did. I blew everything away, so there's literally nothing there. I'm going to show you the variables. Now, the variables that you're going to see here, a couple things that are documented in the README as well. I'm actually setting the instance size here. I've actually got this plugged into my Turbonomic environment so that it automatically resizes based on utilization. So it'll size up and size down as demand changes. So I've actually pulling that in because my Turbo instance is pushing to this repo programmatically as well. So I've got my access and secret. They're stored as sensitive keys. Your SSH key. So your developers now don't have to have their own SSH key, their own AWS access. You can set this up so that you're using a shared environment. So if a developer leaves, no problem, done and done. They never had the keys to start with. You can set your name. I've got a few different things for certificates. Now, what I am going to do is I'm going to actually do a push. This is actually backed by a repo. I'm going to send a push in the background, which you don't see because I don't want to switch screens over and over again. Now, if I go over to my Run tab, okay. So what I've got is right now, I've got a set of code that's plugged in. It's sitting on that GitHub repo that you can get access to. It's public facing. When I actually take the update, it's going to do my initial plan. I've actually got it set to auto apply because I'm brave. So I'm just going to say right here. So it's got 8. Oh boy, sorry, it flew right by. It's got 8 resources it's going to add, which is including all the DNS entries, the EC2 instance. And then what we're going to see in this log as it rolls by is it will get to the point once it does the initial build, and it will actually start the command line installation. Because, like I said, if I look over here, I've stored my SSH key for the EC2 instance that I'm creating inside as a sensitive key inside my repo, so as a variable rather. So it will be able to connect. And then from that point on, Ansible picks up. Now, there's no provisioner for Ansible in Terraform, which is actually not a terrible thing because there are provisioners for Chef and for Puppet and for a couple of other tools. But the truth is it's kind of dangerous because when Terraform sends out a command to go out and do a thing through the provisioner doesn't send back anything other than a 1 or 0. It either worked or it didn't work. You can send error level, obviously, different error levels that are coming back, but it's not verbose. So it's actually kind of a dangerous handoff. So it doesn't actually account for it in the state. So it's a little bit tricky and can be risky when you do that. There's other things you can do. Of course, you can set up notifications. So I've got where I'm going to a Slack. So every time it does a thing, it actually pops up a Slack notification, as if we don't have enough Slack notifications going on in our life. So, okay, so here we go. So as the machine comes up, you're going to see it will do this remote exec a few times. And this is because it's going to keep trying. One thing about AWS, of course, just like everything in the cloud, is eventually consistent, which means it takes longer than you expect, and it will eventually come up. However, you'll see it looks a bit repetitive. But what I like is that Terraform is like a raccoon chasing for a shiny object. It will just keep going until it can get connectivity. And then once it does, it's good. And you can see here it says private key true. So this is a key base. This is not using a user pass at all, so it's completely secure. And then at the end, like I said, what will happen is eventually it'll come up. It's going to take a few minutes. It will do what you need it to do. And then at the end, what we can actually do is we can destroy. I just want to see what the shell will come up in a moment. Now, the good thing about this is, again, it captures state. So if you just go into the state, every time somebody does a thing, it actually keeps track of the JSON output of the current state, what the change was relative to the last one. So here's one where somebody ran a destroy and it was run more than once. You can tell what's doing stuff programmatically. You can run it from the CLI, but generally it will tell you as a warning that it's a VCS backed. So you should do everything through the repository. So every time I do a git push, it goes and runs the state. And like I said, one of the things to be careful about is that it will, if it sees one small change, it has the potential to actually destroy and rebuild it. So here we go. This is the money right here. So you can see it's actually gotten to the point. It finally got connectivity, and it is now doing the install the EPEL release. It's going to deploy Ansible. I would set up then my configuration for my host. My use case that I do for most of this stuff is actually my own internal lab too. I run local Ansible playbooks for like load testing and load simulation. So I just have like cron jobs that run Ansible playbooks to run these different stress machines to look like humans are using the product, which is kind of cool. And so I don't need Ansible Tower. I don't need anything central. I can just, kind of kick those things off. So it's really a proverbial automation cat once you're rolling like that. And then at the end, well, let's see when it'll take a moment. Got to wait for the internet to catch up. It's rather unexciting from that point on, and plus we're at our 20. So I'm going to run back. I'm going to unshare, and the one thing that I really want to impress upon folks is that you want to make sure that this is something that you can do as a team. So getting access to, there's a ton of free resources out there. There's lots of meetups that are going on. Of course, the whole Arctiq team are super well versed in everything Terraform, everything Ansible. So, shout out to those folks because Kyle and Marek and everybody, the entire team that's there, I've been working with them in the community for a long time. So it's, so anyways, hopefully that's helpful. And just double check any questions. Hopefully that wasn't too boring or useless, but veggie burger. Oh, Sebastian. Oh no, veggie burger. Sorry, I'm a very strong meat eater, but it's all good. It's all good. Veggie burger is good for all of us. Oh, hey, there's Kyle. Look at that. It's like romper room for people that are old enough like me to remember that. I see Kyle, I see Elena, I see Arctiq, Aaron. All right. So that's it. I'm going to hand it back to Aaron. Hopefully this is helpful. Of course, you can reach me on Twitter. My DMs are open. It's Disco Posse. You can email me to eric@discoposse.com. And thank you very much. Again, the repo is in the link. We can just share that out if we wanted to, or it's in the recording. So it's on my GitHub. And that is all. Happy terraforming and happy Ansible. So hopefully this was helpful for folks.
Thanks, Eric. There was one question that popped up there at the end. I'm not sure if you have it on your side. Conwar is asking, if I have on-site vSphere infra, can I use Terraform Cloud, or is there something like an on-site Terraform Cloud?
Oh, yeah, that's a great question. Shout out to using Terraform for vSphere, because everything that doesn't everything in the vSphere environment, unfortunately, is rather bad at orchestration. You need Terraform Enterprise. I've tried to think of any way that I can get it to like kick back into my internal infrastructure. So unfortunately, you can't unless it's VMware Cloud on AWS or like unless your vCenter is internet facing. That's the only way, because it has to communicate to the outbound or to the external ports for vCenter. So you can do that. I've done it, which also a rather bad idea unless you're using certificates or other things. But yeah, so you need Terraform Enterprise. I don't honestly know what the pricing is these days for the on-prem. But again, like I said, I think it's like I paid like $900 per year per user or something like that. And I've got a handful of people at my work. So that's it. Like, no, your mileage may vary on pricing, but yeah, thank you. It's a great question. So yeah, vSphere, it has to access your vCenter API. And in order to do that, of course, it has to have some kind of an external face to it. So unless you've got a VPN, from back to something where it can communicate, it gets a little troublesome.
Yeah, and otherwise, I mean, if you have reliable storage and other use cases for using Terraform open source on-prem, you can do that as well and just spawn it on a VM, consume it internally open source, and then shift to enterprise when you need that kind of when the extra feature set. There was another question that came up. You were saying that it's a bad idea to do auto apply or auto approve. Why is that so terribly bad?
More depends how much you trust yourself. Actually, truthfully, if I don't go auto, then I worry that I don't trust something, and why do I not trust it? So I actually do everything as auto apply for the most part, but there are some apps that may not be like sensitive or aware of what time of day it is or who else is in there. So generally, when you're doing shared configs, I like auto apply because I don't like, why the hell would I want to interact with it? So I actually turn it on auto as fast as possible. But in those first initial like tries, you definitely will like the fact that you can kick the tires on it, do your bunch of deploys, make sure it works, do a destroy. Now you're good. Change it to auto apply, and that from that point on. So yeah, sorry, I'm used to talking to folks who have like zero comfort with automation, which is kind of funny. And so it's usually that's the training wheels level is like set up, and you can actually, it's very easy to set it up in Slack. So it actually sends you the link to the confirmation. You just click it, it goes to that's with the cloud implementation. But like Aaron says, I've used Terraform CLI. I use a central control machine. Everybody shares it. You can keep track of things that way. You can even do a web-facing like SSH console, so you can actually run the shell right from the web because it's internal. There's a lot of ways to get at there, so you don't need to be doing Terraform Cloud right away. And also, you'll see syntax is changing, kind of like what you talked about at the start, Aaron, about from facts to info. That's not fun, right? Like we're going to have to go back and refactor a lot of our playbooks, and same thing with Terraform. There's this thing about interpolation syntax that suddenly changed from 11 to 12. And from 12 to 13, inevitably, there's going to be some decent sized changes, and there's good deprecation, which is nice. Thankfully, they did think about that. But no matter how clean your deprecation is, it's bound to happen.
And then you got to hope that everyone's been reading the release notes.
Yeah, sadly, those things are the least read of all things, and I've learned that that's the first place I go.
Yeah. All right. Thanks a lot, Eric. We've had some good activity on that one. I want to shift it over to Marek Anderson talking about Ansible and ServiceNow integration. Thanks, Eric. Please join us for the rest of the stream, and let's continue this on. So let me shift you in, Marek. Looks good.
Cool.
Go ahead.
Thanks, Aaron. Yeah, hi, everyone. My name is Marek Anderson. I'm with Arctiq since July last year, and I will talk today about ServiceNow integrations from Ansible. And we have a very short agenda to go through. It's not a lot of slides. It's more on the demo side of things. So we'll take a look at what are our options to integrate Ansible and ServiceNow. And this talk is intended as a quick start guide for you. The first demo will be about the Ansible modules we can use with ServiceNow, then email notifications we can send from Ansible to ServiceNow, and for example, add work notes to change requests. And the last demo will be about ServiceNow calling to the Tower API. So looking at the Ansible modules that are available, we have the snow_record module, which is only capable of updating or querying a single record from ServiceNow, which has to be uniquely identified. We get back to that in the demos. And there's also the snow_record_find module, which is able to get and update multiple records. Both of these modules require the Python module PySnow to be installed on Controller. Keep in mind, if you have a cluster, you need to have the module installed on all of the cluster nodes. As for the email integration, ServiceNow needs, again, a unique identifier, so it can file the email under the right incident or change request. So here in this example, I just provided a unique change request number. And then lastly, we have the ServiceNow call to the Tower API. So that's pretty much it. We will change to the demo part. So in the first demo, we will just query one change request. So this is the playbook. Pretty straightforward. We're using the snow_record module. Keep in mind you need Ansible 2.5 or later than that to use the module. Provide the authentication against our ServiceNow personal developer instance or your ServiceNow instance you have in-house in production. Provide the change request number we want to change and the table we want to query from ServiceNow. So in this particular case, this is a change request table. And then afterwards, we registered our variable and debug the variable. And from the ServiceNow record, we take a look at the short description. So let's run this playbook. And there we go. We got the short description back from the change request number saying Ansible created this. So this is pretty straightforward. So let's take a look at a different example. I was mentioning earlier that the module snow record is kind of limited. So in this playbook, we will query a change task, and this will fail. So a change task can be assigned to a change request. But regarding ServiceNow, change tasks are that's its own table inside the ServiceNow database. And this is typically not unique. So the same change task number can be assigned to multiple change requests. So just quickly looking at the module call we're doing here, it's pretty much the same, except here we change the table to the change task, and then we debug the change task. Good. Running the playbook, however, as I mentioned, will fail, and it's telling us why it fails. It's saying it's not possible to query or update multiple records with this module. Okay, so this is kind of a bummer. So let's take a look at the newer module. This is available with Ansible 2.9 later. This is the snow record find module. Here we define a query against a certain table inside the ServiceNow database, and we can also specify or limit the number of fields that ServiceNow returns to us. So in this case, we return the number, the change task number that we have queried. We also return the sysid and the short description. So let's run this playbook. And you can see that the sysid, this is actually the unique identifier. We replies back from 3 different change requests that all have the same change target, but the sysid is unique for each item. So this is the primary key, if you will, in the ServiceNow change task table. So this is very helpful, but again, you need to have Ansible 2.9 to use this snow record find module. So the next demo, we will use email to update the work notes inside of a change request. The playbook is pretty straightforward. Again, we're just using the mail module. We have to have an SMTP server available to us, so either our company SMTP or some other SMTP server we can access. We have to have some sort of email recipient inside of our ServiceNow instance. Here I'm using my personal developer instance. And more importantly, we need some sort of unique identifier, the change request number or a reference that we got from ServiceNow. So ServiceNow will be able to file this email. Keep in mind that sending an email out like this is for ServiceNow a new email and not a reply. So you have to change the inbound in ServiceNow to accept new emails and file new emails with the unique identifier into the work nodes. So let's run this playbook. It takes a couple seconds to communicate with the SMT for authentication and sending out the email. And then we will switch over to ServiceNow. So the change request number I'm targeting. And if you look at the work notes below, we can see that emails have been received today earlier. So we don't see our email we just sent yet. Hopefully it will show up in a couple seconds. But if we open the details that I sent earlier this morning, you can see already in the subject line, this is the subject line we've specified through our Ansible playbook and the email body that I've specified. Okay. So let's take a look at the integration of ServiceNow and calling to the Tower API. First, inside of Ansible Tower, we need to specify an application to allow us to authenticate with OAuth 2, to have some sort of secure authentication. So we just define a new name for our application here, select our organization inside of Tower, set the authorization grant type to authorization code. We need to have the redirect URI from our ServiceNow instance. So this is pretty much universal. My developer instance is using the Orlando release of ServiceNow, and the client type will be confidential. Now, once you hit save, this is very important. Please copy and paste the information that is provided to you, which is the client ID and the client secret. As soon as you hit the OK button, you will not be able to retrieve this information again. So make sure you put that in your password safe, somewhere secure that you can copy and paste this information from. Okay, so once this is set up, we need to set up a couple things inside of ServiceNow. One thing we may have to do, depending on our certificate setup, is we may have to import the Ansible Tower certificate. So here I have my FQDN specified for this certificate, and I've imported the certificate chain for my Ansible Tower. Next, we also need an OAuth provider specified. So if we navigate to system auth application registries, we have to define Ansible Tower as a provider. And this is where the information we copy and pasted earlier comes in: client ID and the secret. Set the grant type to authorization code, and also set the URLs accordingly to our Tower API and the redirect URI of our ServiceNow instance. Once we've done that, we have to specify what kind of REST API call we want to do. So we navigate to System Web Services, REST Messages. Here I've created a call called ping localhost. This resembles the job template that we are about to call on the Ansible Tower side. Again, we specify, starting from the top, of course, we specify a name and endpoint. So this is a job template that we are calling, which is the 10. This is the unique identifier you can look at of your job template. Specify again the authentication type and the profile that we are using. So when we our API, we have to do a post call. So make sure that the HTTP method is set to post. Check again the targeting job template that you want to call. Save this and feel free to hit test. This is pretty useful, so you get some feedback. Is this API call working at all or not? Are you having SSL certificate issues, or do you have issues against the Tower API? So once all of this is set up, we want to define a workflow in ServiceNow. So creating a new workflow, we always have the begin and end node, similar to Ansible Tower, if you will. And then we want to create a new node, which is called Run Script. You can find that on the right-hand side in the Core tab Under core activities, utilities, run script, you can simply drag and drop that into your workflow and connect the beginning node and the end node accordingly. So looking at the properties here, all I did is I copied the snippet. I didn't write that myself. You can find that on a blog we can link as well. So all this code is doing is it's using our previously specified REST message, and it's looking up the name and also the HTTP method we defined. So it's only a few lines of code that the script is executing. What we also specified in this workflow is where in the service catalog shall this item be categorized. So I chose to categorize that under services, and this is where we are going to find that. So let's switch over to the service catalog and go to services. Before we hit order on our ping localhost item we created here, let's quickly go to the Tower web interface, change to jobs. And the list is empty right now. And let's click order now. There we go. The job is executing. The timestamp is as of right now. We just hit service now, and we called and authenticated with OAuth 2 against our Tower API and executed this job. So this was, just a quick start guide for you to help you jumpstart the ServiceNow integration side. And if you weren't aware of that, then get your own developer instance. You just have to sign up and click the button, and within minutes you have your own developer instance you can play around with. You have full administrative access to the instance. The instance is also prepared to accept incoming emails. You may have to activate the incoming email settings, but otherwise you have a lot of stuff that you can explore with. And one last thing that was pretty important for me when I played around with that, especially if you're using the Ansible modules for ServiceNow, the playbooks on the playbook execution might tell you that something has changed, which indicates that the ServiceNow API responded, that everything is good, it did the change that you ask the API to do. However, especially in your production ServiceNow instances, you probably have a lot of access controls that allow or deny certain things on certain tables. So please make sure that you're not only looking at the Ansible side, but always check the ServiceNow side as well. Make sure that you can actually see the change that you expect to see on the ServiceNow side. Again, this is because the Python module is not as good or limited in what feedback it gets from the ServiceNow API. So it might tell you it changed something in ServiceNow when it actually didn't. And yeah, that's it for me. So let's see what the Q&A section says.
We don't have too many questions right now, but I did want to call out, Marek, that for sure I think the real money shot for what you showed here in the demo was the part where ServiceNow called into Tower and initiated a job. I'm correct me if I'm wrong, but that's probably the sort of the MVP for like getting, front end for people to select infrastructure, config changes based on a pre-existing Ansible playbook, and then have it show up in Tower and it just does stuff, right?
Yeah, absolutely. Just getting the certificate set up, the OAuth authentication, and then calling to the Tower API. Yeah, I totally agree with you there.
Mm-hmm. Yeah. I mean, beyond that, I know it's like it's the type of interface where you're putting a web interface for a whole different tool in front of a very capable web interface like Tower. Are there any use cases where you think maybe you would prefer to put, a Tower survey in front of a user instead of ServiceNow?
I think it greatly depends on your internal processes and whether you have a full IT service management story or not. If you do, I think ServiceNow is the way to go. as that can be used as your single source of truth. You might also use that as your CMDB. Otherwise, of course, you have the flexibility to go with Ansible Tower Surveys as well.
Okay. Have you heard of or used any of Ansible CMDB?
I actually haven't heard of that yet.
Okay. We had a question about it. I thought we could try with that one. Looks like we'll have to divert that one to Google for Akash. But otherwise, thanks, Marek. Maybe there will be more questions in the end Q&A, but that was also a really good demo. Thank you very much.
Thank you.
Yeah. Ricardo, let's see if he's ready to go. Bear with me a second here.
Hello.
Hey, Ricardo. How are you doing?
Good. How are you?
Good, good. All right. You are up next with Ansible testing with Molecule, and let's see how this goes.
Okay, perfect. So thanks, and thanks, Aaron, for hosting this. So I actually do not have any slides or anything. So I just prepared a demo, and I put everything into a GitLab repo. So after the talk, I will upload or update the meetup page with this link, so you can see everything, all of the steps, and everything for this demo, including the code. So I think we'll just jump right in. So this talk is about using the Ansible Molecule framework for testing, but it's not only for testing, right? So one of the things that I really like about a Molecule is that we can use it to help us develop our role. So while we're developing our role, we can use a lot of the Molecule features to make it easier for us. I like it because before that, I used a lot of scripts or playbooks of my own development to do the same thing. But with Molecule, it makes it easier. We don't have to do that. And Molecule will handle a lot of that, the boilerplate for you, and a lot of the infrastructure for you. So before we jump right into the demo, just a quick note about me. So my name is Ricardo Gerardi, and I work as a senior consultant for Red Hat. I work primarily with Ansible and OpenShift. Been doing that for the past 2 years with many customers here in Canada. And I'm also a little bit of a freak for testing, and that's why I like Molecule. Especially when we're talking about infra as code, then it's really important that we are able to test that code, and we're also able to automate those tests. So let's jump right into the demo. So in order to install Molecule, if you're running this on Fedora, you can actually just use the RPMs that are available. But the recommended way is actually through a virtual environment. So let's just create a virtual environment right now. Okay. We're using the VM module, and then we provide a name for that. So we're just going to call this Molecule VM 01. So this is going to create a new Python virtual environment. So if we go into that directory, and then we source activate, now we're inside the VM environment, and it's a different instance of Python that is running here. So if I type now Python or pip, so I should see that I'm using the Python and pip that are sourced from these from this virtual environment. So I don't have anything here. Pip list, there's no modules installed. So in order to install a Molecule, it's simple as pip install and then Molecule. And we just add the lint here, so it will also download some of the linter tools that requires to lint your playbooks. This is going to to install everything, and it's going to be ready to go in a few seconds. So Molecule is being migrated now from V2 to V3. So what I'm going to be using here is Molecule version 3. Maybe some of you have already used Molecule V2. It's very similar. There are a few changes, and on one of the links that I added to the GitLab repo, is a link to a checklist that one of the contributors created on how to migrate from V2 and to V3. There are a few differences there. So if you're already using a V2, just take a look at that. One of the main differences right now is that some of the drivers there are that we used to have available in V2, like a Vagrant or some of the drivers to provision infrastructure in the cloud, they are not currently available for V3. So if you're using one of those, you may want to stick around with V2 for a little bit longer. But we do have a delegated module in V3 that you can use to create your own playbooks and use that to provision infrastructure in the cloud. Other than that, the two other drivers that come by default with Molecule are Docker and Podman. So you can run these in containers, which is really cool, and that's what we're going to be doing here. So Molecule is installed now. So if you just check Molecule, it's showing that Molecule is also installed in this virtual environment, and we can check the version of Molecule. It's running Molecule 3.02 with Ansible 2.9. So cool. So Molecule is installed, and now in order to use Molecule, so let me go to the roles directory here, where we're going to create a simple role. The role itself, in terms of Ansible, it's a basic role, but it will allow us to see some of the cool features of Molecule and how can it can support us developing that role. So in order to create a role that already uses Molecule, instead of using the Ansible Galaxy to create the role, to provide that boilerplate for the role, you can actually use the Molecule init role. So if we type Molecule init role and give it a name, so in this case I'm going to just call it my web app. And if you do not provide a driver, by default it's going to use the Docker as a driver, but because I'm running these on Fedora, I don't have Docker anymore with Fedora 31, so I'm going to use Podman. So I'm just going to provide the alternate name here for the driver, so Podman, and this is going to initialize a new role, and it will automatically add some of the Molecule boilerplate code there as well. So if you go to the my web app directory, you see that it's pretty standard directory for a role, but in addition to the standard ones like tasks and defaults and files, you also have a Molecule directory, and inside that directory you have a subdirectory for your scenario. You can have multiple scenarios to test different types with different types of infrastructure if you want, and different options. By default, it creates a scenario called a default, and inside that you have molecule.yaml, which is the configuration file for Molecule. So that's basically where you add all of your options to test Molecule. To test with Molecule. So one of the difference between V2 and V3 is that they removed by default the linter options from Molecule. So linter is disabled by default, but I like to link my playbooks to make sure that they are in agreement with some of the standards, right, best practices and everything. So I'm gonna re-add lint here. So basically what you do is you add the option for lint, and you this is actually working as a script now, and you say what you wanted to do. So in this case, we're going to run a script that will run the YAML lint, and then after that is going to run the Ansible lint. So if we just save this file here now with this lint option, and we go back to the root directory of your role, you can lint your role just by executing Molecule lint, and it's going to run all of those linters in your role, and it found some issues here, right? So the lint got a few errors already here. So basically it's saying that because this is a role that we just started, some of the meta information is not filled up. So let's just fix that quickly here, and we can see, right? So let's add some information here, a description. So my new role, not very creative for that, no problem. So Red Hat, and we'll need a license here, and we need some platforms here too. So let's imagine that our role will support CentOS. And we're also going to support this role on Ubuntu, for example. And there's a new line at the end, and the linter will complain about that, so I'll delete that new line. And then you save the file, and then you run molecule lint again, and it will relint the project. But you see that you don't have to do a lot of those things by yourself. You just run the command, and the molecule will take care of doing that for you. So in this case, no errors. So we're good with linting these so far what we have in these playbooks. So now we need to. So the other thing that molecule will do is it will create an instance, which is in this case, because I'm using the Podman driver, it's going to create a container running in Podman, so we can use that container to test our role. So in this case, let me just change a few options there. So instead of calling it instance, I'm going to call this CentOS. So this is going to be our CentOS instance. And I don't want to use this image. I just want to use the basic CentOS 8 image. And I'm going to call this instance name CentOS instead of instance, because later we can add other instances that we can use to test other platforms. Like in this case, we are going to test Ubuntu. Another thing that is nice about this is because it uses Ansible by default as the provisioner, so it will use Ansible to provision the Podman container. So in this case, we can also provide some additional options here for the provisioner. So if we wanted to use like a configuration file similar to the ansible.cfg, we can do, for example, config options. And this is similar to an Ansible CFG file. So for example, just a few options. So I don't want to use, I don't want to see warnings about the Python interpreter that's going to use. Those can be a little bit annoying. And I also want to use some callback plugins that will help us. So while we're doing this, and the other thing that is important for Podman is if you're using Podman, you want to make sure that you don't have pipelining enabled. Otherwise, this is a known issue. If pipeline is enabled for Podman, some of the tasks will fail. So we're going to disable pipelining for this. And now we can, with this configuration, we can list all of the instances that we have that are managed by Molecule. We have one instance called CentOS, but this instance is not created yet. So we can use Molecule to create the instance by typing Molecule create. And this is going to call Podman. Again, it's running an Ansible playbook as the provisioner is going to call Podman to create that instance. And now the instance is created. So if we Molecule list again, we can see that the instance is created, and Podman yes will show that the instance is running. So now we have an instance that we can use during our test. We don't need to keep creating that or deleting or doing that. We can just use that instance for our test. So let's add a first task to our role. So in the tasks main, so this is going to be a web app, so simple one, right? But let's make sure that the HTTPD package is installed. So we're going to use the package module, and we want to install the HTTPD package. And now that we have one task, in order to apply that task to our running instance, we just run molecule converge. And when we do this, molecule will instantiate that role and apply that role against all of the instances we're having. In this case, because we only have one instance running right now, the CentOS instance, it's going to apply that role against that instance. And you see that again, we don't need to create everything. The container is already there, and molecule converge will just apply. So in this case, we can see that the HTTPD package was installed. So for the next iteration, so let's run another task. So we want to edit this again. Let's make sure that the service is started now. So let's create a task to start the service. So we're going to use this. We want to make sure that it's also enabled. So now, when we run the molecule converge again to apply that change, we're going to see that it's not going to apply again the HTTP package installation because it's already there, right? So this is Ansible, right? So it is already there. But if you try to start the HTTPD service, it failed. And it failed because this container is not running systemd. So by default, the container runs as just a sleep process. So it's up, but it's not running systemd. So you cannot run any tasks that use systemd to do that. So we're gonna fix that. In order to do that, we can change the molecule configuration again, and for that instance, we can add a few options to allow that instance to run systemd. So I don't type everything because I'll probably make some mistakes there. Oh, let me make sure that I'll just copy that one from here so I don't make any mistakes. Okay, so basically what we're saying is that we want to export this volume here, which is the C group volume. We want to run this container in privilege mode, so it has the permissions to execute systemd, and we're going to run the init command. So now this instance should run systemd. So we have to destroy this instance, so we can create another one that uses systemd. So molecule destroy to destroy the instance. Now the instance is no longer running, so podman nps, nothing there. And then molecule create again. And it will recreate this instance, and that instance will run systemd now. And then we can do molecule converge one more time, and we're going to apply our role for that instance. Because we destroyed that the previous instance that we're using, now it's going to install the HTTPD package one more time. And then after that, it will start the service. Okay, installed and started. So perfect. So this role is working so far, right? But what we want to do now is we want to make sure that we also test this with another distribution, right? So we want to make sure that our role works with both. So I'm going to destroy this instance one more time, and and we're going to make an update to the molecule configuration file. And we're going to add another instance. So same thing. So we want to add an Ubuntu instance. So just don't type everything. I'll just copy it from here. And now we have another instance. So basically what we have here is an instance that we named Ubuntu. We're using this image here, Docker Ubuntu version 2004, that was created by Jeff Gerling. And the same thing, right? So we have those options to allow systemd to run. The command to run systemd in Ubuntu is different from the one that you use in CentOS. And we're saying that we're using a pre-built image here. So we just save this now. And now if we run molecule list, we're going to see that we have two instances now, CentOS and Ubuntu. They're not created yet. So we're going to create them. And the molecule create now will create both those instances for us. And if you try to run molecule converge, it will apply now our role for both instances at the same time. And that's how one of the things that I like about molecule and how it helps us, develop the roles. You see that in this case, now that we're testing with Ubuntu, we see that for Ubuntu, the role is actually failing, right? And the reason for that is because in Ubuntu, the HTTPD package is not called HTTPD, right? It's actually called Apache. So we need to make a change to our role, right? So if we were developing this role and then just making it available, it would be a little bit harder for us to find those things. So the role still worked for the CentOS, but it's not working for Ubuntu, right? So what we want to do is, instead of that, we want to provide some variables. We're going to load variables that are specific based on the distribution type that we're using. So we're going to use the Ansible OS family fact. So we want to create some variables there. So let's add some variables to our role here. So for Red Hat family, so we're going to add variables there for, let's say, HTTPD package. So that's going to be the name of the package that we want to install. And then we're going to do the same thing for the service that we want to start. So in this case, it's the same. And now we're going to copy those vars into Debian, because that's the name of the operating system family. And then for Debian, we're going to edit. And instead of HTTPD, that's going to be Apache 2. And that's going to be Apache 2 also for the service here. And now we edit our main file here. First of all, we import those variables. Oh. And we're going to say that we want to use the Ansible OS family YAML. So it's going to import the file according to the OS family that it gathers from the facts. And we want to use the variables here instead of the name of the package. So we want to use the name of the variable. So this is going to be the HTTPD package. And this one here is going to be HTTPD service. The only other thing that we need to do here is make sure that for Ubuntu, we want to make sure that the apt cache is up to date. So and we don't want to do that all the time. So let's make sure that if the cache is up to date for the past 1 hour, it's okay, it's good for us. But we only want to execute this one when Ansible OS family is Debian. Otherwise, it's going to try to execute this for CentOS, and then it's going to fail. Okay, so we changed our playbook. And again, we don't have to do everything again. We just do molecule converge, and it's going to try and converge, again, both instances according to the new options. Because we're not really changing anything for CentOS. For CentOS, it should remain the same. But then for Ubuntu, it should now pick up the correct package and service and install and start those automatically for us. Yeah, for CentOS, it's done now. And yeah, install the package for Ubuntu, and now it's good. It's done, right? So let's just execute one more task to complete our role. So let's add some content here, right? So to our web server. So we want to make sure that we want an index file, let's say, right, with some content. So what we're going to do, so let me just get this from here. Again, don't see me typing all of that. Basically, we are going to create an HTML index file, but we're going to use a group name that's going to be different per distribution. And we're also going to use a variable called web content to define what the content on our web server is going to show. So let's add the vars here. So this is going to be Red Hat, this is going to be Apache, and for Debian, this is going to be www data. And we need a default value here for the web content. Just say that we're going to say there is a web server here. And then see one more time, molecule converge, and it's going to apply those changes to the instances. You see, right now we're not really testing it yet. We're not testing the role. We're just making sure that we're using molecule to aid us while we're developing the role by doing this workflow with the molecule converge. We don't need to be creating instance or managing that. We just add changes to our playbooks and or to our role, to our task files and variables, and we execute molecule converge to do that. But let's execute tests now, right? So before we do that, we can actually also log in into one of the instances. So for example, let's log in into the CentOS instance. And now I'm inside the container. I cannot clear here. And inside the container, I can run things like, for example, ps-ef, and I can see that HTTPD is actually running here, right? So you can inspect the container by running molecule login. And if you have more than one container or more than one instance, -h in the name of the instance to check that one. Okay, so now let's verify if our role is working the way it's supposed to work. So now we're going to use the testing part of molecule. In order to do that, we edit. So molecule provides a playbook called verify.yaml that we can use to test. So we can take a look at that. And by default, that verify playbook has nothing really useful over there. So we're going to create some tests here, right? In a previous version of Molecule, it used the test infra by default to do the checks, the verification. In Molecule v3, the default is use Ansible to do that, which I like. I like to use Ansible. And some of the modules that we use most here to do the test is things like we can run the command module, we can run the URI module to get contents from an URL, and we can use the assert and the debug modules to verify if the content or what we're getting match what we should be seeing, right? So again, let me just here. You don't see me typing all of that. So basically what this verification playbook is going to do is it's going to try and get the index.html from the running web server, save that into a variable, and then check to see if the expected content matches what it's coming from the web server. In this case, the expected content is there's a web server here, which is the default content that we're going to create if we do not specify anything. We also want to use the assert module to ensure that we're getting text /HTML data from this web server. And we can also use the debug module just to debug the content so we can take a look and see what's going on over there. So after we create the verification playbook, we can verify if the role is working properly by running molecule verify. It's going to execute that playbook against all instances, and it's going to check if there's an error. We are going to see that error. If everything passes, we see just the green check marks there saying that everything passed. So we can make a change here just to illustrate that, right? So if we want to make a change on the Converge playbook, for example, to add options to our role, for example. So we don't want to use the standard content anymore, right? So we want to change that. So we can go to molecule converge, and you see that the converge playbook is very simple initially. It basically by default only includes your role, and it does nothing else. You can make it more complex if you need. You can create things. You can add more tasks that if you need to do something before you add, the role. Or in this case, we can actually say that we want to specify variables, and we want to say that the web content now is going to be new content just for testing. Okay. And if we save now, and you run molecule converge one more time, now it's going to reapply that role using the new variable, which is going to change the index.html on those running instances. So it's not going to reinstall anything because the instances are already running. But it's going to recreate the index.html file. So we should see this task has changed. And now if you run molecule verify again, now the verification should fail because we're expecting the default content, but we changed the content, right? So it should fail, and that's exactly what we wanted to see, right? So the content doesn't match, right? So we got content that is different from what we're expecting, right? So we want this content now for the testing. So it's going to execute that one more time. Oh, not the molecule, the verification actually. So the verify one, and this is the new content. And then if you run molecule verify one more time, now it should pass the tests again. Perfect. That's exactly what we wanted to do, right? And then, so the role is ready now. It's tested. It's working on both instances. The last part of this, what we can do is we can actually use molecule to run the entire workflow, right? So if you're just using molecule for testing, you can run, instead of running the converge separately or the verify as separate steps, what you can do is run a molecule test, and that's going to execute the entire workflow. So you can see here, that's the workflow that is going to execute. It's going to import any dependencies, it's going to lint the playbooks, destroy instance if they're running, create instance, converge, and verify, and do everything, right? So the nice part about this is that because it does everything, that's how we can automate testing using molecule. We can even use this in CI/CD pipelines by executing molecule tests every time. For example, we commit something to Git, and it's going to run everything and ensure that whatever your changes you were making are still going to work with all of the tests and are not going to break your role or anything. This is going to take just a couple minutes to finish up because we're running the entire flow. But while it's doing that, one thing that I wanted to show is how you integrate this in a CI/CD pipeline. So there are examples in the documentation, but if we go to the repository for this demo, I created GitLab CI.yaml file here as an example. So let me click on that file. Sorry, it's because I was increasing the size. Okay, so if we click here, so this is one way how you can integrate this with CI/CD pipelines. And the format here is going to be slightly different depending on where you're executing. For GitLab, this is the format. So we basically use the image with Docker, and we run another Docker container called Docker Dend, which runs Docker inside Docker. And then basically after you instantiate that, you run a before script, which updates, install Python, Docker, and set up a few prerequisites for your test. And then basically you have your test stage where you run the Python 3 to install Molecule, and then you just cd into the directory for your role and run Molecule test. And this is going to execute, because we don't have any other options, this is going to execute every time we make an update or a commit or a push into this repository, right? So we can see, for example, pipelines that I executed before. So this was ready here, right? So we can see the logs for every time that this pipeline executed. And it's basically the same output that we get from Molecule tests over there, right? So it's executing all of those tests and make sure that they all pass. If we go back here, yeah, the Molecule test completed now successfully, and our role is ready. Aaron, I think over to you.
That was very good, Ricardo. Lots of good stuff that I'm sure people like. And it's good that you covered so much of it. There are a few comments and sort of questions about it, but you ended up answering the question with the last part of your demo, which was good. The part about linking container lifetime to test execution, and the fact that you can drop it into a pipeline like that looks even more interesting.
Yeah.
There is another question in here. Can you open? Looks like there's a Molecule 3 demo repo. Someone's curious if it's private or public.
Yeah, so that's the repo that I'm using here. It should be public now.
Okay.
Yeah.
All right.
It's public. So
okay.
Yeah. So yeah, so that's the Molecule 3 demo repo. That's the one that I created with all of the steps for this demo and all of the code that I use. So you can pretty much replicate the same thing if you have Podman on your computer. If you don't, you can actually do pretty much the same thing using Docker as well. So yeah, Podman is just, again, because I'm running Fedora, and Docker no longer runs on Fedora.
Well, I guess I've got a sort of a question leading after that. In your opinion, Podman versus Docker, which way would you go and why?
That's an interesting question. Right now, I'm going everything that I do with Podman. I'm no longer using Docker for pretty much anything. The main reason for that I like Podman is because I can run the rootless containers. So we don't need to run. So Docker basically opens up even if you're running with your own user, it opens up a socket into with root access to your machine, right? And Podman doesn't do that. And the other thing is that for Podman, you don't need to have any kind of daemon running. Podman is just a standalone tool. You run Podman, and it will run the containers. And when the container is no longer running, you have no footprint on your system.
Yep, sounds good. So another question that I think might kind of bring this around for everyone who may or may not have had time with Molecule or understands it fully. What did people do to achieve the same task before Ansible and Molecule was around?
Yeah, so in my case, for example, I used a lot of scripts. So I would code things in either shell script, or even I would create some Ansible playbooks myself that would run part of what we're doing with Molecule today. I would run my own Ansible playbooks. So with Molecule now, I don't have to do that anymore. I basically leave all of the boilerplate and the infrastructure management for Molecule, and I can actually focus on creating the code for my roles, or the business content, right?
All right, and I guess it's fair enough because everyone has to, write Ansible and all this stuff in some sort of editor. I noticed, unlike a lot of my colleagues who are all using VS Code, you're using Vim, and I was actually just curious for my own interest here, which Ansible autocomplete plugin you're using.
Okay, so I'm actually using two things that helps me, developing Ansible playbooks with Vim. It's for autocomplete, I use the plugin called Completer. And I can also drop some links for that, in the meetup if anybody's interested. And I also use the Ansible Vim plugin, which is a plugin to make it easier to develop playbooks, with some, the proper code highlighting. It has integration with snippets, so I could use some snippets there instead of typing everything, right? So there's a few, and you can integrate that also with Ansible Link. So while I'm typing and saving the playbooks, it would do automatic linking of the Ansible task files and playbooks.
Interesting. I'm gonna have to take note. So we're at the point where, yeah, thank you for your demo. That was very interesting, and there was a good bit of activity in the chat about it. We're at the point, everyone else, where we're open to any other questions or general Q&A, Ansible Meetup related if you like, or about any of the demos, and we'll see if we can get any of the presenters to jump in and answer the questions if you have any. So I'll leave a minute or so for that, for everyone to catch up and maybe write something in. In the meantime, we have just a few links we can toss out at you here. If you're not familiar with Ansible, this is your first time even hearing about it, which would be surprising. They have their website. I dropped in here. We have a link for our own Arctiq GitHub page, and then we have our website. And then Terraform we're going to call out too, because we use a lot of Terraform in automating things. And I believe we're going to try to get the presenters to drop any of their public GitHub links into the chat, or we'll set up some social media sort of writing thereafter and send everyone's content through Twitter or LinkedIn, so you can catch up with the presenters directly if you like. Doesn't look like we have too much other activity in the chat. And if
I just saw a comment here from Peter, right, saying that the repo still seems private. Yeah, it should be public. I'm not sure if it takes a little bit to replicate. It was private earlier today, but then I made it public a few hours ago, so I can see it public here on my end. If you have a problem, then yeah, just drop me a note or something on Twitter, Ricardo Gerardi on Twitter, and then I can take a look. Okay,
so I guess we're going to call it a day then. We're ahead of schedule, which isn't a bad thing, and this has been a pretty good experience considering this is normally an in-person thing, and normally it's I guess it's surprisingly a lot easier to do this in front of a room of people than now in front of the internet, which could be any number of people, right? And we had a pretty good turnout, it looks like, and I think the demos were very thorough. That was a good thing. And beyond that, I think we're gonna call it a day. So everyone, thanks for coming out, and this has been a great experience so far, and I hope everyone has a great rest of their week. Bye-bye.